What's up, everyone? This is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev, and WorkshopFest.dev. Welcome back to the JavaScript Master Podcast. Today, together with Miško Hevery, who is an CTO and Builder.io, creator of Qwik, Angular, AngularJS, and co-creator of Karma.js, we will tell you about everything that happened around Qwik. Hi Miško, how are you?
I'm doing well. Thanks for having me, man.
For those who don't know you yet, please tell us about yourself.
Hi. I'm Miško. I am a CTO at Builder.io. I run the engineering department where we build a headless CMS product. And we're also working on a Qwik and Partytown. Basically, one of the things we're really interested for our customers is to make sure that their websites have the best possible end user experience, and that means speed. And so we're working on these two cool technologies, Qwik and Partytown, to make sure that the website is as fast as possible. And I think that's what we're going to talk about today, right?
Yeah, exactly. So what exactly you do at Builder.io? So what does your workday look like?
I think it's split. About halfway is just dealing with, internal running of the engineering organization. And the other half of the time, it's split working on Qwik and Partytown. And so maybe we talk about a little bit about Builder. So what Builder is a headless visual CMS. What that means is that, imagine you're like Target.com or, Nike. And so you want to build a good experience for your customers. And one of the things that the marketing people need to do all the time is change their website, right? All the time. A/B testing, different products are on sale, different sales are happening. And as an engineer, that's the last thing you want to do is you want to change the percentage in sales or anything like that, right? And so you want to enable the marketing folks to be able to just change it on their own. And so there's lots of headless CMS systems. But what's unique about us is that we're visual. So instead of basically having access to a database and marketing person needs to know that this field controls this text on a UI, they actually get to see the UI in real world and just go and edit the UI any way they want. For those of you who are kind of more familiar with it, normal headless CMS systems work on the level of fields. And as an engineer, you have to data bind fields to all the things you want to have the end user or rather the marketing person to be able to control. We work on the level of components so that instead of data binding bajillion fields, you just have to data bind a couple of components. And then the marketing person basically controls the content of the component. Now, the reason why this is interesting is because existing headless CMS systems are agnostic to what technology you use. Because we're giving you a component, we're not agnostic. We have to actually give you an Angular component if you're using Angular in the backend, and a React component if you're using React, and so on and so forth. And that would be a ridiculous amount of work for us. And so we created this thing called Mitosis. And Mitosis is an open source project that allows you to write code once, and it will then spit it out for every single framework out there. And that's how we kind of bridge the gap to make sure that we don't have to do create a ridiculous number of SDKs. And so Mitosis is open source, and people actually use Mitosis to create component libraries that, you write the component library once, but then it's available in Angular, React, Vue, Svelte, Qwik, and so on and so forth. So that's kind of exciting. So Builder has a lot of open source technologies that we like to share. We kind of believe in open source, and it's one of the things we do.
Yeah, that's amazing. That sounds really cool.
It is.
So before we started to talk about Qwik, I wouldn't be myself if I didn't ask you about Angular. I know that this podcast is supposed to be dedicated to Qwik. I know it's your new baby and you seriously love it very much. I'm correct?
I love all my kids.
I also know that you are creator of AngularJS, about which once I wrote a book which completely changed my professional life. For that, I would like to publicly thank you so much now.
Oh, thank you. You're welcome.
Yeah, so
good to hear.
Please tell us how you started your adventure with Angular. What was the main driving force you to create this amazing framework, and what goals did you set for yourself at the beginning of this journey?
Yes, it's a good question. So before Angular, I actually worked, before even Google, I worked in Adobe, and Adobe was working on a product that was supposed to compete with Flex. At the end of the day, like Adobe actually ended up purchasing Macromedia, and so Flex became kind of the default thing. But I got very familiar with Flex, and I was like, building applications using Flex is actually very nice. And I was kind of surprised that we didn't have anything equivalent in JavaScript world. And so when I kind of joined Google and I started building web applications in Google, I was like, this is kind of backwards. Like Flex was so much nicer. Like, could we bring this idea of component model into the browser? And kind of this is where AngularJS was born. Now, originally, the goal of Angular was that it should be for people who are non-developers. So the idea was like somebody who is a web designer who understands HTML but maybe not programming should be able to build like simple applications. And that's the reason why AngularJS was very HTML centric. Everything was kind of from HTML, and only later we kind of turned it into a full-on framework, which is kind of in contrast with frameworks like React, which are very JavaScript centric first, and then HTML comes to it in kind of that as JSX. So that's kind of the impetus of how I got started with AngularJS. And I think one of the things that the reason why it became so popular, I think, is because it introduced kind of the new paradigm. Before AngularJS, we had jQuery, and it was kind of you added behavior to the page on as needed basis. With Qwik, with Angular, it became a component model, and basically the whole application was expressed in the component. And from the AngularJS, I like to think that I like to think that I had at least a small part to do, because a lot of secondary frameworks came out to be everything from React, Svelte, Vue, and so on, and they all kind of copied the basic ideas of how a framework works from Angular, and then they added their own framework. They added new DX paradigms, new approaches. Lots of innovation happened in it, but fundamentally, all of these frameworks kind of work the same way. And I think that's a kind of a good segue to Qwik, because Qwik is different. Qwik isn't like these other current set of frameworks.
Qwik offers the fastest possible page load time, regardless of the complexity of your website. Qwik is so fast because it allows fully interactive site to load with almost no JavaScript and pick up from where the server left off. What does it mean?
Okay, so let's start with defining what resumable means. So back in the day, if you remember, when first virtual machines came out, and I'm talking like VMware, what I found fascinating was that you could, you take your host machines, and in your host machine, you boot up Linux. So now you have Linux running inside of your host machine. And that's exciting, but that's not really what we're here to talk about. What really blew my mind is that once the Linux booted up inside of the host machine, you could go and open up, let's say, a word processor and start writing a letter. And then halfway through writing a letter, you could save the virtual machine into a disk. And then you took that file and you could send it to a different computer and open the file up, and you would be exactly where you left off previously, right? The thing that you wouldn't do is you didn't go through a boot up process, right? You didn't boot up again, and the application didn't open again, and then it didn't restore the document. It just literally the machine just woke up with the application open and your document in there and the cursor blinking, and you could type, right? And this is what I call a resumable. Right? Because once you opened up the second time, the code just resumed where it left off. There was no replay. There's no, in the case of a framework's replay, or the framework case of an operating system, the replay would be rebooting the system and then reopening the application, right? You just continue where you left off. And this is kind of what we mean by resumable. Now, how does it translate to web? So in the web, it's basically the same exact thing, right? So what we do in the web today is we SSR the output, right? That's the server-side rendered content. We show it to the user, and so they have a good experience in the sense that they immediately see the site. So that's good, but they can't interact with it. And the reason that they can't interact with it is because, we haven't attached the listeners. And what this means in practice is that the page has to go essentially through a boot process, right? It has to boot up the framework. It has to boot up the application. It has to re-execute the application. It has to figure out where the listeners are inside of the templates, and then reattach the listeners to the DOM. And all of this work is what I call essentially replaying, or you could think of it as booting up, right? And so all of the frameworks work this way. And because of that, all frameworks have this particular thing they call hydration, which is like, how exactly do you restore a static HTML page that came from the server into an interactive application in a way that is, kind of consistent with the user experiences. And this restoring of the system, this hydration, is what's expensive. If you navigate to any website and you open it up in DevTools and you look at the performance, what you will see is that there's huge amount of JavaScript that has to execute in order to get the page up and ready, right? And so the obvious answer is, like, in order to get the application up and ready, we need to reduce the amount of JavaScript. But the question is how, right? Because all the JavaScript is there presumably for a reason. And the answer is, well, it's there for a reason because it's booting up the system. And so what Qwik does different is that it knows how to serialize everything that it needs on a server in the same way as a VM machine serializes everything to a file. And in this particular case, it's not a file. It's just an HTML with extra attributes and extra JSON information. So we serialize all of that into a page, into HTML, and send it to the client. And then in the client, we don't have to go through the booting up of the application, running the templates, figuring out where the listeners are, attaching of the listeners. None of that stuff needs to happen. We are just ready to go. In the same way as your VM machine that you restored from a file is just ready to go exactly where you left off.
So is it like a snapshot or something like this, yeah? So
you can think of it as a snapshot, yes.
Okay. So how it corresponds to the dynamic data from the server? So when the data on the server change, every minute or whatever.
So once the application is up and running, right, same exact things apply. So like if you have an application that shows you stock quotes, right? Then when it wakes up on the client, it has to somehow connect back to the server and start fetching the data or what have you, right? So in that sense, once the application wakes up, it can do everything the existing application can do. There's no difference. It's the waking up that's different, right? So why is it that existing frameworks have to do hydration? And the answer is because, well, at the end of the day, what hydration really wants to do is figure out where the listeners are. Right? Like which button has a click on it. And if I click the button, like what piece of code do I have to execute, right? If I have an add to shopping cart, then I have to have a listener attached to the button that says, if you click on this button, then you have to go and execute the piece of code that adds an item to the shopping cart. And then that piece of code probably, updates the shopping cart, which means that the shopping cart has to get re-rendered, right? But in order to figure out where the listeners are, existing frameworks say, well, I'm going to start at the root component and I'm going to render the root component, and that root component will render child components, and those will render child components, and so on and so forth all the way down. Now, the frameworks can do this in an efficient way in the sense that they know how to reuse existing DOM elements so that they don't recreate everything. But nevertheless, the effect is that in order for the page to be interactive, all of the JavaScript has to be downloaded and executed, right? Now, the way Qwik is different is that Qwik serializes information such as, oh, this is a button and this button has a listener. And if you click on this button, then you have to go download this piece of JavaScript and execute it, right? But none of this stuff has to happen eagerly. I just have to leave that information with the button. And so the way this works in practice is that you take the framework, right? You take your components that your application. And by the way, you write the application in a very similar way as you would write it in existing framework. So from the DX perspective, this is very, very similar. And then you run it on a server. And on the server, you kind of figure everything out. And instead of just saving the HTML, which what most frameworks do, you also save information as in like, there is a click listener at this location. Right? Existing frameworks don't save this information because it turns out saving the click listener is actually complicated, and we can kind of get into the weeds of it. But existing frameworks don't save this. And so we save this piece of information. We also save information about the state of the components. Some frameworks can do that. For example, Next.js will store the state of your application inside of a special tag. But we go further because it's not just about the state of the application. It's also about internal state of the framework. And as far as I know, no framework knows how to serialize its own internal state, except for Qwik. So Qwik serializes internal state as well. And internal state is important because we need to save information such as if you modify this property on a shopping cart, then I have to remember to go and update the shopping cart component. And so I need to also not only know that relationship between this property and the shopping cart, I also have to understand the relationship that, oh, this shopping cart requires me to download this component's template so that I can re-render it, right? And so there is a lot of things that have to happen in the UI, or rather on the framework side, so that you can serialize all of the information that you need. I guess the way to think about it is when the framework wakes up on the client, it needs to be able to reason about the application without the application source code being present, right? The way most frameworks solve this problem is they say, like, I want to reason about the application, as in like which component do I have to render when, and what are the listeners, and what are the states, and all this information, right? But the way they recover that state is that they execute the whole application from the root, right? And that kind of forces all this problematic behavior of like downloading too much JavaScript and so on and so forth. And so the thing that's different in Qwik is because Qwik serialized all the state at the server, it can look at this data and can reason about like, does this component have to be downloaded? No, it doesn't, because nothing has changed. Does this component have to be downloaded? Yes, because this property has changed, I have to re-render it. And because it has all this information, it can reason about it and do just the bare minimum necessary to continue running the application. Yeah, so the reason I say it's not on the same time, because when you say it's on the same time, it implies that a server instance has to be present in order for the browser to do its work. And that's not the case. As a matter of fact, one of the things that we care about a lot is you typically run the server-side rendering only once, and then the result of that goes into a CDN cache, and then millions of other customers can get the CDN cache so that the server never has to be involved again, because running things on a server might be performance intensive. So from that point of view, like we don't do that.
The main goal for creating a Qwik was the performance.
Specifically, not just performance, specifically the startup performance, right?
Okay.
Because you have a lot of frameworks that claim later the fastest in terms of updating the content on a page. But I'm going to argue that like even if you have the slowest framework and you use that to build an application, your still application is plenty fast, right? The reason why we are concerned about the performance is not that the actual running application is not performing. It's that the application startup performance is a problem. So to give it more concrete, like imagine somebody sends you a link on Twitter and says, here, check out these awesome new shoes. You click on it and you come to the shoes and you're like, oh yeah, they look great. I want to buy them. And you push the buy button and nothing happens. Well, why is nothing happening? Well, because you're seeing the result of this particular URL, which is server-side rendered and maybe cached on a CDN, and so the CDN can quickly return to your HTML and browser can quickly render it. But now the listener isn't attached, and so now you have to wait until the whole application downloads again, executes on a client, until the framework kind of reconciles everything and says, aha, the listener for this button is right here. And on a mobile device and on a 3G, that can take as much as 30 seconds. And so now imagine you are a customer who's like looking at the shoe and you're like, maybe I'm not that interested. And then you leave, right? And so you never complete this particular purchase. And so Amazon understands this very, very much. And they spend an enormous amount of effort to making sure that their sites are as fast as possible. Now, the thing that Amazon has learned is actually they cannot get this performance with any existing framework. This is why they don't use any framework. They actually are in the good old days of essentially the PHP on the back end and jQuery in the front end. I don't know if that's what they actually use. That's not the point. The point is they generate static SSRs, and then instead of using a framework, they just send necessary JavaScript to kind of make individual buttons work, but not to kind of make the whole thing work, because every time they look into a framework, they realize the performance of this isn't going to cut it, right? There are two things going on in there. One is personalization, right? So they need to be able to personalize the content for a different person. What it means is that when I show up to my Amazon account, it will show me that like these are the items in your shopping carts, and will say, welcome back, Miško, and all this other information, right? That's specific to me. And if you go to their homepage, the products that they show are also specific to me, right? So they can't just run a CDN hit and return a generic content for me. I mean, they could, but they have since learned that that's not going to produce as much of a response as if they personalize the product for myself, right? And the second problem they have is that like once they send all this HTML to the client, the application has to wake up, right? There's basically this hydration step. And so this hydration step is also very expensive. And so together, their kind of conclusion, which I think is absolutely correct, is that you can't really use any of these frameworks. And so they essentially are doing it the hard way and hacking everything together, just with pure JavaScript. And this is where kind of Qwik comes in and says, like we would like to have a mental model of the component mental model that kind of AngularJS introduced, that kind of a starting point. We think that's a great mental model, but we want to also be able to do amazing personalization, execution time on a server, and also amazing wake up time on the client, so that a site like Amazon can totally be run on top of Qwik. And I know it's a very big claim, but like that's the goal of what Qwik is trying to do.
Okay, so how it works on the server side?
So the whole trick to Qwik is that it works pretty much the same as normal framework. Actually, before I answer that question, I want to just kind of make another comparison that I think what's important to understand is how this is different. So existing frameworks basically are concerned with rendering on the client.
Yeah.
Right. That's the kind of what they care about. And we have meta frameworks that kind of add the server component to it, but they're limited by what the framework can do. The thing that's different about Qwik is that Qwik cares about the whole lifecycle, which means server-side rendering, serialization, bundling, prefetching of the code, sending to the client, and hydration on the client, and of course, rendering on the client, right? So Qwik's goal is the whole thing, not just the rendering on the client. And because Qwik cares about the whole thing, we can do certain things that other frameworks cannot do. So for example, most frameworks don't care about bundling. In other words, if you go use Angular or Svelte or React or whatever, like you are just writing application for your need. And like at some point later, you're like, oh, I need to do bundling. So like, let's use Rollup or Webpack or something like that, right? Qwik, and because of that, Rollup can't just like move code around in any way it wants. It has to make sure that it semantically doesn't break anything, right?
Yeah.
Whereas in Qwik world, Qwik has this thing called optimizer, which is something that runs in front of Rollup or some other bundler. And the optimizer knows that it can actually move code around in a way that would be considered breaking for other frameworks. But because the optimizer and the Qwik runtime understand each other, they understand the rules that they're allowed to break, right? And so as a result, the optimizer can do things that would be considered not valid in other frameworks, but are perfectly valid within the context of Qwik. And this is kind of what allows Qwik to take your whole application, break it up into pieces, etc. So the big difference with Qwik is that Qwik cares about the whole thing end to end, not just the rendering, the whole thing end to end. And that kind of enables cool things. So the question is, how does it run on a server? On a server, it basically runs in a very similar way as any other framework. That in itself is not different. What's different is how we serialize things. So most frameworks really only know how to serialize application data and nothing else. Qwik, of course, serializes application data, but it can serialize other things, like, for example, closures. And closures are hard to do because, well, code, that's easy. That's just JavaScript. And data, well, that's JSON. But closure is a mixture of the two because closure closes over other variables, right? And so it's a mixture of code and JavaScript. And so Qwik knows how to serialize that. Qwik knows how to serialize things like promises, which is kind of mind-blowing.
Yes.
It knows how to serialize other things like, dates and so on and so forth. And it serializes not just the application data, but also the framework data. So it serializes things like listeners to things. Where exactly are in the DOM tree, you have listeners. It serializes boundaries for the components, serializes information about under which conditions do these components have to get downloaded and executed. And so you end up with a much more kind of a fine-grained world where you can reason about, you can delay basically a lot of work on the client. So the rendering part is not different. The rendering part is essentially the same exact thing as the other framework. What's different is that there is a serialization part that saves all this information into the HTML in the form of extra attributes or in the form of basically a JSON in such a way that the client can then start up and does not have to do a full reboot, right? It can just literally just continue where it left off.
You mentioned that Angular.js was HTML-centric and it was very easy to start and everybody can use it. Angular is for developers. It's not for everybody. You have to know a lot of things to start. It's great, but the threshold is much, much bigger. And how about Qwik?
Yeah, so how to get started with Qwik quickly, huh?
Yeah, exactly.
So I think the world has changed. At the time of AngularJS, we were in the world of jQuery, right? In jQuery, you just added an extra script tag onto your page, and all of a sudden, you kind of progressively enhanced your UI in any way you wanted. And AngularJS was the same kind of way. You added a special script tag, and all of a sudden, you had kind of new capabilities on your browser, right? But as you pointed out with Angular, React, Vue, and Svelte, and all the other new frameworks, right? It's more JavaScript centric. Like you start a JavaScript project, and the HTML is kind of the after fact, the artifact from the execution of this particular code. And so Qwik, in that sense, follows the same exact paradigm. Like if anything, Qwik needs to understand both the server and the client, right? And so it has more kind of things that it has to control. But to get started, you just do npm create Qwik at latest, and it will create a basic setup for you that you need. We have adapters to work with Express, with Cloudflare, Netlify, and just about any other popular backend system. But the thing to kind of understand is that Qwik needs to control both ends of the spectrum. Like it needs to don't control the client and the server so that you get all of this magic. But the other thing is that Qwik is also composable. So typically when you think about a server-side rendered stuff, you really are server-side rendering the whole page. One of the things that we wanted Qwik to do is to be personalizable, meaning that just like on Amazon, when you come and visit, like I want you to put my name somewhere and to put your, the content of my shopping cart. But doing so completely invalidates the page, right? It can no longer be served out of a CDN, because then if you serve it out of a CDN, then everybody gets the same exact content. So what if you could take the page and break it up into lots of smaller sub-applications per se, and then each sub-application can be cached independently. So maybe the header cannot be cached because that's specific to me, but the hero image certainly can be. And maybe I am of the particular category of a consumer that likes 3D printers, and therefore, maybe they will show me a 3D printer products, which is cacheable for everybody who falls into that category, right? And so one of the things that Qwik can do is that it can assemble itself from smaller chunks that are themselves CDN cacheable. And because of that, you can gain personalization. You can have complex pages that are still personalizable, and it's fast enough where the cost of executing all this stuff on a server is not a problem. So
how you can achieve it? So how you split this up in these small chunks?
Yeah, so we have this thing called containers, and you can think of each container as a separate application. And the interesting thing about that is that the container is just a piece of HTML. But in that HTML, the HTML is fully self-contained. It contains everything the application needs to resume. It contains the URLs of where the JavaScript lives or where it has to be downloaded. It contains the state, the the listeners, et cetera, et cetera. And because it's fully contained inside of the HTML, it works really well with CDN caches, right? So you take the whole application, you break it up into smaller chunks, and then you can think of it as you have a multiplexer kind of an app running at the edge, right? That talks to the other edge servers and says, I want you to give me a header. And that one says, well, I need to fully render the header because that's specific to the user. And then over here, it says, I would like you to show me the hero image for a person who likes 3D printing, right? And so it says, oh yeah, but I already have that cached. And so I can just return to you this huge chunk of HTML that's fully cached, etc. And then, at the bottom, it says, show me some default products for, this region of the world. Great. I also have that cached, and I can just return this for you as well. So in this way, we can assemble a whole application very quickly. And because each of these applications can wake up independently, and they don't necessarily share state in the global way, they can still share state, but individually on pieces. The result is that you can have fully customizable output that is both fast and has a fast startup on the client.
To whom would you recommend Qwik?
I think whoever is using a framework today, whether it's Angular, Svelte, Vue, React, or any of the existing frameworks, if your problem is served by those frameworks, then it will also be good, very well served by Qwik. There is really no difference between what you can achieve in Qwik or any other existing framework. The difference is the startup performance and the ability to kind of break your application into pieces, as we talked about, but there isn't a difference in terms of capability. So whoever is, building basic stuff can do so in Qwik as well.
As I could understand, the idea of Qwik is that no matter of how big is your application, Qwik is always flat.
Yeah. So we talk about this idea. I'm actually trying a new marketing term here. We talk about how the Qwik applications are streamable, meaning that instead of downloading all the JavaScript up front, they stream the JavaScript on as-needed basis, right? Like as you're using the application, as you interact with the different parts of the application, more and more JavaScript shows up. And because of that, as you point out, our startup cost is constant. It doesn't matter whether it's a simple hello world or a humongous, complicated, Amazon e-commerce website. The startup performance is the same and constant. And that is not the case for existing frameworks. And I think that's the biggest differentiator, right? And the end result is that it produces a wonderful experience for the end customer. I also like to point out, we are gotten ourselves as an industry to a very interesting spot, which is that when the framework, when the website is slow, we go and blame the developer. We say that developer messed up. And to me, it's really interesting because, first of all, I don't think it's the developer's fault. And the reason is that, well, first of all, it's not helpful to look at it that way. But I think more importantly, if that was the case, then you should see that in the real world, there would be plenty of examples of fast e-commerce or fast websites in general, right? And you should see that, there are some slow ones, but there are many, many that are fast. Actually, what you see is that no real production website is fast. They're all slow, right? And so if the end result is that all the sites are slow, then maybe it's not the developer's fault. It's unfair to blame the developer if everybody's having the same exact problems. And so I actually would like to say that the problem isn't the developer. The problem is that the tooling kind of sets us up for failure, right? Because all of the existing tooling produces JavaScript proportional to the complexity of our website. So as our application goes more and more complicated, the amount of JavaScript we download and execute increases with the complexity of the website. And that's not scalable, right? No, even if some frameworks are more flat than others in terms of how fast they grow the amount of JavaScript, at the end of the day, they all grow JavaScript. And so instead, I'd like to think of it from the point of view of we need to change our approach. We need to change our tools. We need to change our approach so that the developer shouldn't be the one responsible for thinking about it, right? Even if you don't think about the performance of the website, you should be able to get good performance. And that's just not the world we live in today.
Do we have something similar like a Qwik on the market? Did you heard about something like this? Or Qwik is totally new philosophy of writing web app?
There's always something that's already on the market that is similar, right? So Google internally has a framework called Wiz.
Okay.
And Wiz is quite different from Qwik. It's not really the same thing. But nevertheless, it has this resumable property. It has this property that it starts up applications very, very fast. And you use Wiz all the time. Every time you go to Google search engine, you use Wiz. Every time you go to Google Photos, you use Wiz. And the thing that these applications have in common is just how unbelievably fast they are, right? And one thing that always surprises me is that if I want to spell check my word, the fastest way to do that is to paste it into Google and have it render it a fully customizable page, right? Like just for me, there's no CDN caching involved in there. And it can correct my spelling of the word faster than any other way I can do this. And so that kind of shows you the power. And now people will at first look at it and say like, well, but it's just a simple page. Actually, it's not a simple page at all. Because if you type complicated things into Google, like for example, if you type in an equation, you'll get a graphing calculator page. If you type the name of a movie, you'll get a complicated UI that allows you to choose and select different theaters and movie times, etc. So Google actually has the specific problem, is that the potential set of UIs that they can produce is actually very, very large. And so there's no way they can possibly send the JavaScript for all of it. Instead, they have this resumability property that says, okay, actually, let's just render the page, and there doesn't require any JavaScript to kind of get the page interactive. And then as the user interacts with the page, we download more JavaScript based on what the user is doing. So Wiz is another example of this. Again, it's not open source, so that's just internal to Google. I've also heard of eBay working on this thing called Marco, and a new version of Marco 6 that's supposed to come out later this year. And this particular thing, I haven't used it firsthand, but apparently they also have resumability property. So it is not definitely unique. And I think going forward, my prediction is, I'm not sure if Qwik is going to be popular or not, that I cannot predict, but I absolutely think that resumability is the way going forward. I think the new generation of frameworks that will come will definitely incorporate resumability as their key property, because you get huge wins in terms of performance, and you get to break this problem that the amount of JavaScript produced is proportional to the complexity of the page. And instead, now the amount of JavaScript produced is proportional to the user interaction, right? And since user cannot interact with all of the page all at once, that takes time, you will get much better performance for the user.
So for the user perspective, Qwik is the winner for me for now, because it's user fight for the performance.
So we have a homepage. Before I got to Builder, we had a homepage, builder.io. And the Steve, the founder of Builder, he spent a lot of time making sure that the homepage is as performant as he could possibly get it, because the homepage is actually built using Builder, and so it showcases the product. And because the page was built on top of mitosis, it was easy for them to try the page done in Angular, the page done in React, Vue, Svelte, Solid, whatever framework you want. And one thing he found out is that no matter which technology he tried, the performance was about the same, right? And again, this goes down to the fact that all frameworks have to have this hydration step. And as a result, maybe some are a little faster
you
here
have
or
to
some
wait.
faster there.
Yeah.
But at the end of the day, this code has to get downloaded and executed, and there's no way around it. And so when I first met him, I kind of showed him Qwik, and we very quickly ported the homepage to Qwik. And it was absolutely shocking. The page went from something like 30 or 40 on Google PageSpeed score all the way to 100, right? And it really, Google is telling you what to do on Google PageSpeed score. It says, you're executing too much JavaScript, remove JavaScript. I was like, yes, I know, that's obvious.
But how?
How?
Yes.
Right? That's the $1 million question. Like, how do you get to remove this JavaScript, right? And so this is the thing that Qwik figured out, is basically how to remove JavaScript so it doesn't have to boot up. And we kind of find that this works just for about any website. So any website or any application, whether it's complicated, interactive or not, it doesn't matter. When we remove JavaScript, we are making that application inherently fast because browsers are really good at rendering HTML. They're super fast about HTML, right? The hard part isn't the HTML. The hard part is the JavaScript that we're sending to it. And the JavaScript comes in two forms. It comes in the first-party code that you have written yourself, but it also comes in the form of third-party code that you have to add to the website. Things like Google Analytics, HubSpot, Amplitude, Facebook Pixel, and so on. And this is also a problem. And it's kind of a worse problem because while you may have control over the code you have written, you don't really have control over the code, the third-party code, because it's like a business reason. You need this for this business reason. And so what are you going to do? How do you not include it, right? And so for this, we have Party Town. So we basically figured out how to execute third-party scripts in a web worker so that they do not impact the first-party performance or the interactivity of the user. So the solution we have is basically for third-party code, you take your third-party code and put it in the web worker using Party Town. For first-party code, you can use Qwik instead of the existing technologies. And the benefit you get is that in both cases, you are significantly reducing the amount of JavaScript that has to be executed in the browser. And therefore, even on slow mobile devices, your applications is way, way faster.
Okay. What will be the best use cases?
For things that are very UI intensive, like Google Map, it probably might not be the best solution because there is an overhead to talking to the web worker thread, right? Yeah. And so it might become laggy. Like it should work, but it might become laggy. It's best for things where speed doesn't necessarily matter, like Google Analytics, right? Like it doesn't really matter at which point you send the fact that the user has visited your website. Does it send now or does it send 200 milliseconds later? It doesn't matter, right, to the end result of what's happening. But it does matter hugely to the experience that your customer has on your website. Okay,
understand. So what is Qwik City and why do we need it?
Okay, so most frameworks, I have the framework, which is like React, Vue, Svelte, Solid, etc., that talks about the rendering part. And then usually on top of it, there's some kind of a meta framework. Like, for example, React has Next.js, Svelte has SvelteKit, and so on. Vue has Nuxt, I believe. And so these meta frameworks allow you to basically do file-based routing. In other words, you lay out your components on your file system in a way that you want them to reflect inside of the URL. And then voila, you can kind of very quickly build beautiful pages that are consistent, they have a shared layout, and so on and so forth. And so Qwik City is the same exact thing. It allows you to do just that. The interesting thing about Qwik City is that it usually tree shakes away, meaning that because how lazy the frameworks, the Qwik is, like out of the box, just behaviorally, oftentimes the Qwik will look at it and say, actually, you don't even need this Qwik City, and never actually gets shipped to the client. Because, that's kind of what Qwik does. Qwik kind of looks at the application and says, actually, this component is static, this component is static, there's no interactivity here, only these components are interactive, and so only these components actually need to have behavior shipped to the client.
How is Qwik related to your company?
So that's a good question because, Builder is spending a lot of time and effort on building this in open source, and so why is it that we're building it? And so the answer is Builder makes headless CMS systems. And when I say headless, what it means is that you are running your own architecture, like either React or Angular or Svelte application. And a headless CMS system gives you a field, right? It gives you essentially a JSON that says like, when it comes to time to render a title, render this text over here from this database. And when it comes time to render a sale, percentage or whatever, render this text over here, and so on and so forth. And so because the fields are all static, so they're just kind of a JSON object, right? It's compatible with any existing framework out there. But it also creates a problem, which means that existing customers, they come and they say like, we are going to use, React or Svelte or whatever existing technology we have. We build our homepage. we interact with the fields, using the JSON from the headless CMS system, and therefore the engineers don't have to go and update the UI all the time. Well, it turns out that actually creates a problem in two ways. One is there is never enough fields. The marketing always comes back and says, yes, but I know I can change the title, but today I want to make the title red. And the engineer's like, oh yeah, well, I haven't given you data binding for that bit, and I have to go back and like change some code, and now you can data bind this over here. And then marketing comes back, is like, yeah, I can change the whole title to red, but actually I just want to change the first word to red. Right? And so engineers are constantly being like, okay, so this headless CMS system basically gives you levers or knobs by which you can tweak the UI, right? And what you're discovering is that no matter how many knobs you give to the marketing person, the marketing always comes up with like, they want to do something else that just does not fit the current mental model. And so you end up with this bizarre paradox, which is that you have both not enough of these knobs, and at the same time, the marketing is complaining like, there are thousands of different fields. I don't know what they all do. Like, can we simplify this? Right? And so there's this weird paradox that like, it's both not enough and too much. And then you go to production and you have your application, and the all application, as we kind of discussed, have a really bad performance. And as we kind of talked about it, usually people blame the engineer, which isn't really fair. But in the same way, people are looking to blame something. So they're like, oh, it's the headless CMS system that you're using that is slow. Actually, that's not the case, because, well, the headless CMS system just returned a piece of JSON that was returned out of a CDN cache, and therefore, the amount of cost that added to it is measured in a few milliseconds. So that can't possibly be explaining why your website is taking 30 seconds to boot up on a mobile device. And so most headless CMS systems just basically choose not to solve this particular problem. And they say like, well, that's not our problem, that's somebody else's problem, right? But Builder actually wants to go a step further and says, actually, no, we want to solve this problem. Not only do we want to make it easier for you to work with your marketing department, we also want to make sure that the end result is actually faster than anybody else can do. And so this is where Qwik comes in. So there's two parts that are kind of different. First of all, Builder, instead of giving you a JSON, which is just a bunch of things that you have to data bind all over the place, and that means now you have to like put it like, hundreds, if not thousands of different locations inside of your source code. Instead, we give you a handful of components. Basically, the marketing says, I want to control the hero, the big text thing the banner
exactly.
on the top.
Hero, yeah.
And so what happens is you convert the hero into a Builder component, right? So it's a single component, and it's not a million different data bindings part. You take the HTML or the JSX behind the component, and you handed it over to the Builder. But you don't hand all your source code to the Builder, just what's behind the hero component, right? And now the Builder, with our beautiful editor, the marketing can just like do whatever they want within the confines of this particular box, because at the end of the day, what they're doing is just modifying HTML. So if they want to make the first word red, they can certainly do that, and it's not a problem. If they want to change the sale percentage and schedule it to go at midnight, they can do that. If they want to do A/B testing, they can do that, right? Now, engineers love this because, well, now marketing people are not bugging them for these little things like, I need to make the first word red. Well, let me go change some binding, right? Instead, the marketing folks are a lot more sufficient. Marketing love this because, well, first of all, it's visual. They see what they get, but also they don't have to learn different like fields. Like, it's not like this field controls this field controls this, right? It's like, well, I see what it is, I know what it is, like it's exactly what I see, and there's nothing to learn. And so now we have customers who are using that, but they're still having bad performance. And so can we go back and give them Qwik? Can we come to the customer and say, you know what, you're using, let's say, React and Next.js. How about you switch over your homepage over to Qwik? And the end result is that your homepage is going to be significantly faster. However, there's a problem, right? One of the things that the customers can do is they create existing components inside of their existing framework. So let's say they're working with React, they will create a product detailed card that the marketing people can drag and drop onto different parts of the page, right? So they don't they can't modify the content of the product card because that's written in JavaScript somewhere inside of the bowels of your thing. But they get to choose where to put the card and how many cards and what data bindings to have to this card and things of that sort. But if this card is written, let's say in React, and we say, well, you homepage is in Qwik, that's not going to work. So one of the things that we are also working on is that Qwik can actually run React components. And in this way, they can have a page that wakes up amazingly fast, just like Qwik does, because there's no JavaScript to run. But at the same time, they can use the React component that, server-side rendered. But Qwik is smart enough to lazy kind of hydrate that particular component when it's time to do so, whether it becomes visible or the user interacts with it or something of that sort. And so this way, the customer can have best of both worlds. Now, from a business point of view, that makes a lot of sense, right? Like here, we are simplifying your workflow, right? Instead of having this field, you now can have a visual editor. And instead of having a website that might be potentially slow because of all the existing technologies that require hydration, we actually have a way for you to deliver on a site that is personalizable, which, by the way, is hard to do with the existing technologies. And then it can be, they can have a very fast startup performance, and which is really important for e-commerce websites, right? So think like Nike, Target, and so on. They would love to kind of increase the performance, the startup performance of their landing page. And so Qwik and Partytown are like key technologies that we are building in open source so that we can take them to our customers and say, look, you can do this and you can improve your website performance. And that in turn, increases our revenue because like all of a sudden customers love us even more because, their websites are even more performant.
Can you recommend for our listeners some two books, like one technical and one non-technical?
I love reading non-technical books. Not the non-technical, right? Reading books that are necessarily about software engineering, like outside of my field. And a book that I always recommend and I absolutely love is Thinking Fast and Slow. Okay. It's by Dave Kahneman, I believe. I'm probably butchering his name. And another person, and I have since forgotten. And it's an interesting book because it talks about essentially how your brain is broken, right? It's it comes at it from the point of view of like, oh, we think we're irrational human beings. And then here is a book, it's a very thick book, that basically says like, well, let me show you all this different way that we are broken. And the interesting thing is that it's not that we're broken in different ways, and therefore, as an average, we behave the correct way. It's like, no. We're all broken in the same way. And so we systematically make the same set of mistakes. And I find this book fascinating because it's kind of like a manual for your own brain. Because you think you're invincible, you think you know everything, you think, like it's obvious to you, right? And then you read this book and you go like, oh, right, my brain is just lying to me and it's really good at it because, well, it's the one controlling the thinking. And so, of course, it can lie to you in a way that you kind of don't even notice. And so I love this book. I think everybody should read it.
Amazing. What about technical?
I actually recently read an interesting technical book. It was called The History of Rocket Fuel.
Okay.
And I find it fascinating because it basically went through the history of like, how did we get to use the propellants that we use today? And it's kind of funny because you think that these questions are either easy or obvious or like, oh, you needed a propellant. So clearly you would mix, hydrogen and oxygen or, kerosene and oxygen or whatever, and you get different kind of things. But actually it turns out that if you look at the history, these things were not obvious at all. And people have gone through huge amounts of experimentation and trying different things before they settled on these technologies that we have today. And before it looks completely obvious in the retrospect, right? And there are different fuels. There's obviously fuels where you have oxygen, or the oxidizer is separate from the fuel itself. By mixing it, you kind of can fire it up. There's these fuels like for example, oxygen and let's say hydrogen requires a spark, right? You have to kind of get it going. There's other fuels where you can mix two things and they naturally just self-combust. They're called hypergolic fuels. And there are even crazier fuels, which is like they already have the oxidizer mixed into the fuel and they just need a spark, which seems crazy. But it's just a fascinating read, and I just kind of find it interesting, especially from the point of view of how we always tend to think like everything is obvious after the fact, when in reality, once you see the hard work of the people who have went through this process and you just realize how much time and effort they put in, you kind of recognize that things aren't really that obvious. Things are only obvious after the fact, after somebody tells you the answer, that things are obvious. But before then, none of that stuff is obvious. And it's true not just for like rocket fuels, it's true for software engineering, it's true for daily life. Same thing for frameworks, right? I think resumability is one of these concepts that will just become, over time, will become so obvious that everybody's going to be like, why did we even, did this whole thing without resumability? Clearly, this is the way to go, right? But it's only obvious after the fact. It's never obvious beforehand.
What kind of person is Miško, and how do you see yourself?
I don't know. I think I'm a regular person, just like everybody else. I am just passionate about a particular thing, which happens to be frameworks. I am passionate about, well, actually, I'm more passionate about just making the experience better for both the end user and the developer, right? Like, I want to have sites that are just fastest possible sites. And at the same time, like, I don't subscribe to like, oh, like the developer just has to work harder or whatever. Like, I think we need a better set of tools. We need a better set of abstractions, better set of mental models. And I just love working on this particular problem and trying new things and experimenting, right? And I also have been working on this problem for a very, very long time. I know Angular is, maybe like 13 or 14 years old. But even before that, as I mentioned, I was in Adobe. I was already working on frameworks. So it's easily that I've been working on frameworks more than 15 years of my life, professional life. And so, yeah, I just love it. I think it's a lot of fun.
Everybody knows that you did a lot of things in your life. Do you have some hints for our listeners regarding self-organization?
Oh, self-organization. I am horrible at self-organization.
Oh, yes.
For me,
definitely.
I would love to take them.
Definitely, yeah.
Yeah, I think self-organization is like this myth that like everybody talks about, but nobody actually knows how to do it. No, my only hint for people is that I find like everything else in life, it comes down to persistence. And that's what I tell my kids all the time. Is like, they always complain like, I don't know how to do X. I'm like, how do you get better at it? And they're like, oh, I'm sorry I asked. Did you practice, right? And there is no other way around it. And so, like for me, software is, I started playing with computers when I was in like, I think, fourth grade. So like when I was, I don't know, 12 or something. And so I just been doing it for a pretty long time. And none of this stuff is hard, right? Like there is no one particular concept in software engineering that is like so unbelievably difficult that, like only very few people understand it. Like, no, like everything is understandable by everyone. It's just a matter of how much time and effort you want to put into it. And the thing with software engineering is not that any one thing is hard, is there's just so much of it, right? The breadth is huge. And you can drill down into deeper layers in any direction you kind of choose. And so what puts off a lot of people from software engineering is that they expect like a quick win. They expect like, oh, I'm going to, learn this and then I know. And the reality is like, no, it's kind of not like that. It's like you just have like
a lot of layers. Yeah.
Yeah. You can dig forever anywhere you want. Right. And so it becomes this game of like, so which layers are worth digging into and which I can just trust that they'll just do what they do. I think what's kind of interesting about me, though, is that I actually come from the background. I actually studied computer engineering, what means I studied the hardware part of things. So like layout of chips, chip design, digital circuits, and things of that sort. And I started the kind of low level. And then over the years, as I went to different companies, I went from chip design to embedded systems, to backend systems, to databases, to front-end systems. So I kind of have a unique path through it all. And so I kind of always joke that I'm probably the only JavaScript engineer that knows how a transistor works. But I think it's kind of cool. It's just the amount of time you spend on it is really what it comes down to.
So what about work-life balance?
Oh, yeah. I would like to get a work-life balance. How is your work-life balance? I think it's okay. there are times where you're like excited to work on something and you just have to do it, and nothing happen. Nothing. You can't do anything else until that one is solved. But there's other times where you're like, it's weekend. I spend time with my kids, we go places, etc. Or you just have to have me time for yourself and do whatever is required for you. So it's a combination of a lot of different things that comes into it. And I don't think anybody really. I think it's like self-organization, right? Like everybody talks about it, but nobody actually has it. So everybody talks about work-life balance, but I don't think there's anybody who actually has it, because there are times where you look at problem and you're like, this is unsolvable. This is a dead end. I'm going to throw away years of my work, and you just want to leave. And then you settle on it, you think about it, and you're like, what assumptions can I break to kind of get myself out of this mess? And then usually you find one or two assumptions that you can twiddle a little bit or break a little bit or shift a little bit or something. And then slowly you can break it up and make progress. And so it just comes in ebbs, right? Sometimes you're on top of the world. Sometimes you're like, this is dead end and you'll never go through it. And just like I talk about having patience and just like spending the time about learning these things, like you just have to have like almost like faith that like eventually you'll figure this out. If you put enough time into it, you'll crack this problem in one way or the other.
Miško, thank you so much for today's podcast, and see you at the JS Poland and NG Poland conference in October.
I'm excited, and thank you for having me. This was so much fun.
Thank you so much.